Well, now I'm about to give you this official definition of orthogonal, which is a funny word. Yes, it is a funny word. So it's kind of like perpendicular. Vectors u and v are orthogonal if u dot v is 0. Now, orthogonal, what does that mean? If u dot v is 0, the angle between u and v is pi over 2, 90 degrees for degree fans. But that's that. It's like perpendicular or normal, if you ever heard of one line being normal to a plane or something like that. That's another word like perpendicular. Perpendicular refers to lines and planes. A vector could be normal to a line or normal to a plane, but vectors are orthogonal to each other. Now you got it. Okay, so here's a couple examples. Given the vector 3, 1 and the vector 2, negative 1, find the angle between them. Okay, well, for the first one, we're going to say cosine of theta would be equal to the dot product, which is 6 minus 1, so 5, divided by the length of this vector, which is, can you see it? I hope you could see it, square root of 10, times the length of this vector, square root of 5. And right now, without even looking, you should be able to see right away that since it's positive, this angle is going to be an acute angle. So 5 divided by the square root of 50. How about if we make that 5 divided by square root of 50 is 5 times the square root of 2. So that means 1 divided by square root of 2 is the cosine of the angle. But wait, it doesn't say find the cosine of the angle between them, it says find the angle between them. Well, the angle whose cosine is 1 over the square root of 2 would be pi over 4. Okay, problem number 2. Guess I can get rid of all this. I want to keep the cosine of theta though, but cosine of theta, problem number 2. The dot product of this vector in three-dimensional space and this vector in three-dimensional space, let me see, it would be 2 times negative 3, that's negative 6, plus 3 times 2, that's plus positive 6, plus 1 times 0. Ah! Cosine of theta, hey, I don't even have to find, I mean, I might just as an example for you, but I mean, I know my numerator is 0, so right away I know those vectors are orthogonal, the angle between them is pi over 2. But the length of this vector is the square root of 14, and the length of this vector is the square root of 13. So, alright, if you want to multiply that out, I don't especially feel like it, but I guess it's a square root of 183 or something like that. I don't know, maybe that's not right. Square root of 182, that's better. Square root of 182. And who knows what that would work out to be, but I'm not going to worry about that. But point is, our theta is pi over 2. Okay, a third problem here. So let's start off with a clean slate here. Third problem, cosine of theta is the dot product of these two vectors. In our third problem, that would be 2 times 1 plus negative 3 times negative 2. So that's positive 6 plus 2 is 8 plus 1, 9. Dot product is 9. And that would be divided by the length of this vector, which is, hey, we just did that one, the square root of 14, right? We did one similar. So square root of 14 times just wanted to dot that. Don't want that dot. Sorry. Typos galore here. Square root of 14 times square root of, I haven't calculated it yet, square root of 1 plus 4 plus 1 square root of 6. Square root of 14 times the square root of 6, which is the square root of, we'll call that 9, divided by square root of 84. I'm trying to think if that simplifies. I guess 2 square roots of 21. 2 times the square root of 21. Okay, now listen, when I go to find what the angle is, I'm just going to have to say it's the arc cosine. My software, if I want the arc cosine, I just type A and then type cosine. So, and then I'll just copy and paste this in here. So if I simplify that, that didn't help much. But it looks pretty. But I guess what I wanted was a decimal approximation. So let me go for that decimal approximation. All right, 0.19000. Now remember, this is a radian measure. So if you want to see, well, gee whiz, Mel, how many degrees is that there number there, huh? Well, I guess we could calculate that. We're going to multiply that by 180 and then divide it by pi, and this will give us, I'll do another decimal approximation, and this will give us approximately how many degrees? About 10 degrees between these, well, actually closer to 11 degrees between those vectors.